Very similar for what we discussed and for the examples listed here in the notes. Very similar. Okay. So please everyone focus with me. If you have any question, let me know. So we mentioned what is Karnaugh map? What's Karnaugh map? Anyone remember what we mentioned regarding Karnaugh map? What is it?
The way to simplify Boolean expressions.
Okay, perfect. But is this like analytical technique or graphical technique?
It's simple.
Graphical.
Graphical. So who answered me now? What codes?
Code 30 for me.
Code 3 and the first one?
3-0.
Oh, 3 and 30. Okay, Jim, thank you. Thank you. Yeah, exactly. It's graphical technique and used to simplify Boolean expression. And we did comparison last time for using to simplify the Boolean expression using logic algebra or Boolean algebra and using Karnaugh map. And we noticed that Karnaugh map, if we did the proper design for the problem, like choose the properly adjacent ones, and everything is fine, so it gives a directly simplified expression. So we don't have to use Boolean algebra to simplify the expression. And this is very big advantage because, you know, may you apply Boolean algebra not exactly, or you did errors, you do errors, so the final result will be not correct. However, Karnaugh map gives you directly to simplify the maximum simplification you can get. If, as I mentioned, you draw the map correctly or properly. So we mentioned if we have two variables, so we will have 2 to the power 2 or 4 min terms or 4 boxes in the Karnaugh map. If we have 3 variables or 3 inputs, so we will have 2 to the power 3 is 8. 4 inputs or 4 variables, so we will have 16. And this is the maximum Karnaugh map we use in our course here. More than 4 variable, this will be very big number or min terms or squares, and this actually beyond the scope of our course here. So we study up to n equal 4. But do we have 4 more? Yeah, we have Karnaugh map for more than n equal 4. But it's not for this course. Most likely for graduate studies. So we did examples for how we get the min terms or the function, the Boolean function in terms of the min terms. And we studied Karnaugh map with 2 variables. So this is the standard form of the map, the Karnaugh map for 2 variables. Assuming the variables are x and y or a and b. So we put x here and y is here, and then start from 0, 1, also from 0, 1. The min term is inside. Each box has a min term. The numbering of the min terms is M0, M1, M2, M3. So if we are given truth table like this, so we look at where F is 1, and this means this one here corresponding to a product term. So we got the product terms here. Is this for our traditional way to get F as expression? So we get the product terms. We look at F, where F equal to 1. And then we determine the product terms. So as we mentioned, if we have the variable is 0, so we take this variable inverted. If the variable is 1, we take it as it is. So we got M1, M2, M3. So F equal, or in terms of F1, F2, F3, so F equal F1 plus F2 plus F3. We add the product terms, and then we use Boolean algebra to simplify these expressions based on what we studied before. Like we know y inverted plus y is 1, and x plus x inverted y is x plus y. So we got the expression here for F in minimum, or I mean the maximum simplification. But after we did some Boolean algebra, we applied the Boolean algebra. However, using Karnaugh map, we draw the map, the Karnaugh map, we put the standard parameters as we did here, and then the main terms just in order, starting from here, M0, M1, M2, M3. So M0 is 0, M1 is 1, M2 is 1, M3 is 1. After we fill out the Karnaugh map, we look at the ones, adjacent ones. We group adjacent ones. So we start with 8. We are looking first for 8 adjacent ones. We don't have 8. So we look at 4 adjacent ones. We don't have 4, so we look at 2 in this order to get the best simplification at the end. Yeah, we have 2 here, but if not, so we look at 1. We take 1 individually as product term. I mean, we take 1 individually and we get the product term for this just 1. So we have 2 here. So we have here 1 and 1. So we have 1 here and 1 here and 1 here. So these 2 ones, do you see the cursor? Do you see the cursor? Do you see the cursor?
I don't see it.
Yeah, I don't see the cursor, but I
You
do
see
see
the
when you draw.
writing, but you don't see the cursor?
Yeah.
You see it or not?
I see the
I
writing,
don't.
but I don't see the cursor.
Okay.
Yeah.
Okay. So, but you see this cursor here, right?
Yeah,
Now I do,
now I
yes.
can see the cursor.
Okay, okay, got you. So we have 1 here and 1 here, so we can take them as a group, right? As a group here. As one group. Then we have this one left. We have this one left. As long as we can take this one in a group, this with this one like this one and this one despite we already took this one in a group before, but still we can take these ones in another group. This gives us better simplification. So we have two groups. Each group has fundamental product. So say F1 and F2. To give the product terms, rules. If the variable within this product term has one value, so we take this variable and we put it in the product term. But if this value is 1, we take it as it is. If it is 0, we take it inverted to keep 1. If within the product term, the variable has 2 values, and these 2 values are different, like we have 0, 1 or 1, 0, we skip this variable. We don't consider it in the product term. But if the variable has 2 values and they are the same, so if these 2 values are ones, so we take this variable into consideration. Say x is 1, 1. So we take x. But if the variable has 2 values with like 0, 0, so we take x inverted. We'll do more examples, so we will get this better when we do more examples. So we have F1 here and F2 here because we have only 2 groups here. Each group is corresponding to a fundamental product. So this group is F1. You call it F1. And how we get the product term? Again, we put the group into a box. We determine the box which contains this group. So the box here is this one. And then we look towards x variables or horizontal. It may be more than one variable here, more than one. So we look in horizontally. So what we see, x is one value, which is 1. So we take it as it is. F1 is x. Within this box of the group, we look towards y. So we can see y has 2 values, 0 and 1. So 2 different values. So we skip y from this product term. So F1 actually just x. Now we look at F2, again within the box of F2, looking towards x direction or x variable. We have 2 values for x here, 0 and 1. So what we do? What we do for x?
We skip.
Perfect. We skip it. What's your code, sir?
7.
7. Thank you, Chin. It's two values, different values, so we skip. Now we look at towards vertical, in vertical direction or towards y. So what we have for y?
1 value.
1 value. What is the value?
1.
So what we do? We take y or y inverted.
Y.
What's your code, sir? Thank you.
31.
Thank you. Exactly. So F2 equal y. So the solution, or F total F, the Boolean function is F1 plus F2, which is x plus y. So if you look at x plus y here, we can see, you see from Karpov map, we got it directly. But for traditional way, we have to do simplification using Boolean algebra. If we have three variables, which n equal 3, like x, y, z, or ABC, so this means how many minterms we have, or how many squares we have inside the Karnaugh map.
8,
What's that?
8,
8. Perfect. What's the code?
28.
28. Stephen, thank you. We have 8. 2 to the power 3 is 8. And how we organize the Karnaugh map for 3 variables, as you see here. 2 variables of the 3 is here, and the last one is here. So if we have the variables x, y, z, so this will be x, y, and z here. If we have the variables a, b, c, so this will be a here, b here, and c here. Just a way of organization, okay? And then for the 2 variables here, x, y, we 2 variables. So this means we have 2 values, 0, 0, in order. I mean, not in order as decimal number. No, I mean in order. I mean, we should have only one exchange. We should have only one exchange. So 0, 0, we start with 0, 0, which is 0, 1, 0, which is 1. Then if we put 0, 1 to get 2, so look what happens. We have 1, 0, then 0, 1, if we put it directly after 1, 0, so we have 2 changes. 2 changes in one transition. This doesn't work with Karnaugh map. We have to keep only one transition. So we have to jump and put 1, 1. After 1, 0, we have to put 1, 1. Then 0, 1. So we keep only one exchange. One may say, oh, but here we have 0, 1, 3, and 2. Yeah. We jump. We jump here. So 0, 0, 1, 0, 1, 1, 0, 1. This is the way how we arrange Karnaugh map if we have 3 variables. For z, it's just 0, 1. Either 0 or 1. And when we put the minterms inside, so again, remember we need to jump here. As this is square, we need to jump. How? We have M0 in order now. Okay, we have M0, M1. Okay, M0, M1, M2, M3. After M3 is what? M4. We put M4 here, not here. Because we have to jump, because this corresponding to 1, 1, not 0, 1. So after M3, we put M4 here. Then M5, then we go back to M6, M7. Okay. These numbers, of course, we take it from the truth table. The truth table, the minterms goes in sequence. M0, M1, M2, M3, M4, M5, whatever you have here, you have to go in sequence. Since the inputs arranged like this, 0, 1, 0, 1, then 0, 0, 1, 1, then 0, 0, 0, 0, 1, 1, 1, 1. Okay. Any question here so far?
Can you explain again how do you know which midterm goes to which box?
How? How I
How
know?
do you know? Yeah.
How I know what?
Which midterm goes to which box?
Okay. Okay, first of all, we agree this is the standard Karnaugh map here for 3 terms.
Yeah.
This is a standard one. But I try to explain to you how it is done like this. But this is standard. I know some people use a different way. It's okay for if they feel comfortable with that, it's okay. But for me, as I show you here, this is the standard 4. So we agree this is the standard one. We put it in this way. If we have 3 variables, X, Y, Z. If we have A, B, C as inputs or variables, so we just put A, B here and C here. Okay, now your question. How we fill these min terms? But again, the sequence of the min terms, like as we see here in this standard Karnaugh map. M0 here, M1, M2, M3, M4, M5, M6, M7. Now how we fill it? As I mentioned before, we fill this from the truth table. Or it is given, like we will see in the examples. If from the truth table, the first min term is M0 here. M0 corresponding to these inputs and this output. M1 corresponding to this, M2 to this, and so on. So you start from M0, M1, M2, M3, M4, M5, and so on if you have more. Now, we mentioned F is better to, for F equal to 1, it's better to circle and look at ones. Most likely, F equal 1, most likely less than F equal to 0. But here, like we have more ones than 0. Whatever, let us continue for F equal to 1. So where is F equal to 1? At M1, M2, M3, right?
Yeah.
So in this Karnaugh map here, I go to M1, I put 1. Here I put 1. M2, I put 1. M3, I put 1. And the rest will be zeros. Okay? So I fill out this. One may say, oh, wait a minute. Here we have only 1 0 and the rest are ones. So it's better to put M0 equal to 0. And then automatically you put all but this I mean I talk here about 3 variables, okay? I just take example for this truth table, okay? But of course this truth table for 2 variables, not for 3. We'll do 3 also, but I just give you hint about the way how to fill out based on this question, how to fill out this. So say you have M0 is 0 and the rest are ones. So I put M0 equal to 0. I choose 0, and then the rest will be ones. Okay?
Okay, thank you.
That's it. Okay, perfect. Here example for using Karnaugh map with 3 variables. We are given the Boolean function in terms of the min terms. We mentioned this F can be given in terms of the min terms like this. Or what other forms we may give in F? Here F is given in terms of the min terms here. 3, 4, 6, 7, these are the numbers of the min terms. What other forms may be given differ than these min terms? What other form?
Truth table.
Truth table is given as truth table. Perfect. What's the quote there?
28.
Thank you, Stephen. Thank you. Or another form. What other form we can get if
SOP,
what is that?
sum of product form.
Perfect. Thank you. Some of product terms like we have it before, like this one, for example, it can be given. Yeah, we got this from the truth table, but it can be given this, and then you do the truth table. So this is a form of product terms. It can be given like this. Okay. So one of the forms that we may be given F is this one, which means in terms of M term. Min terms, I mean. So if x, y, z equal sum or sigma 3 and 4 and 6 and 7. What this means? 3 means M3 is 1. 4, we did that before. When we have F equal to like M1 plus M2 plus M3. So we said F equals sigma, open brackets, 1 and 2 and 3. So vice versa here. So we have this sum, 3 and 4 and 6 and 7. So this means M3 is 1 in the Karnaugh map. M4 is 1. M6 is 1 and M7 is 1. And we need the Boolean function, or F as expression. Of course, in terms of the product term. So we have the standard Karnaugh map for 3 variables. And we look at M3. M3 here is 1. M4 is 1. M4 here is 1. And M6 is 1. And M7 is 1. We put all ones, then the rest are zeros. Put zeros. The rest are zeros. Since you finished mapping once, so just the rest put zeros. So what we have here now, what is the next step after we draw the Karnaugh map? What is the next step?
You
Professor?
check for
What is that?
Yeah, Professor, I'm gonna leave because it's raining like really hard, and I don't want my computer on. Is that okay?
Is this bank?
Yeah.
Okay. Okay, drive disabled, man. Okay.
I'm not driving. I'm at my house, but like it's
so
like
you
very
you-
loud. Like you
I
could hear
thought
the
you are in
thunder.
your work and you go home or whatever.
No, I'm in my house, but like I feel like I'm gonna get struck by lightning.
Okay, so stay until you get outage or whatever.
Okay, I'll get struck by lightning.
Yeah, since you don't have to leave. Yeah, just to stay until May it works. Who knows? Because this is important actually. It's better to to follow than to read it by yourself. Okay. Okay, guys. So as I hear someone said, grouping ones. Yes, grouping ones. So we look at, first of all, we look at 8 adjacent ones we don't have. We look at 4 adjacent ones we don't have. So we look at 2 adjacent ones. So we have this one here and this one here. So we put them in one group. And this one here and this one here. So we took them in another group. One may say, oh, we have one here and one here adjacent. So should we take it in one group? Why? You don't have anyone left. So you don't have to do more, to add more product term. It's useless. Because you already take every single one in group. So you don't have to take more groups. We don't get benefit of it, okay? But if we have single one, yes, much better to put it in a group, of course. Now, we need to get the product term for, say, this is F1. So what is the product term for F1? So we look at in this direction here, in direction of XY. The box is here. The box for this group is here. This is the boundaries for this group. So we look at the variables within this bound. So we look horizontally towards X and Y. So what we take here, so say F1. So what we take, F1 equal to what here for this portion?
XZ inverted.
We look at XY direction. We look at this in this direction. Between here and here. So what is the variables we have? X is 1, 1. Y is 1, 0, right? Or Y is 1, 0. X is 1, 1. We mentioned this before, right? So what we take?
X?
Should we take Y?
No, we should take X
Why we don't take Y?
because it changes.
It changes, has different values. Within the boundaries of this group, fundamental product or product term, Y 1 time is 1 and 1 time is 0. So what we take? We take 1 or 0 or 0 inverted, I mean. We can't because we have 2 different values. So we skip it. Okay? But look at X. X is 1, 1. This means we have 1 value. So what we take here? X or X inverted?
We just take X.
X, perfect. Now please continue with me, the one who answered me. Now look at the boundaries in the vertical direction. So here, between here and here, within, for the boundaries of the product term. So what is the value of Z?
0, 0.
0, Z? 0, 0? What you
Yeah.
got?
Yes, the vertical is 0, 0, 1, 1, 1. Or 0, 0, 1, 1. I mean,
No, Z, for Z here, we have 0 and 1.
okay.
Look at here. 0 and for XY, look at here. This for Y, this for X. So Y is 0, 1, 1, 1. X is 0, 0, 1, 1. For Z, it's just 0 and 1. So between, for within the product term, what is the value of Z?
Z inverted.
So Z is 0, so we take Z inverted. So for this one here's fundamental product F1 equal X Z inverted. Okay? What's your code, sir?
27.
27. Thank you. Now for the other product term here, F2. These are the boundaries of the box. So one tell me, please. Looking towards XY, what we should take?
YZ.
I'm talking about XY now. So what we should take?
Y.
Why?
Take
Why?
Y.
Why?
Because
Why?
Y
Why?
is
This
1,
is
1.
the-
Y is 1, 1.
1, 1. Perfect. So we take Y. Why we didn't take X?
Because X is 0, 1.
Means two different values.
Yes.
Okay. Great. So far, so good. Looking for the vertical boundaries here, from here to here. So what we take?
Z.
Z.
1, 1.
One,
the same.
What do you mean by 1, 1?
Oh, you said the vertical values of Z?
Z, what is the value? What is the corresponding value of Z for this product term?
1.
1, just 1. Between this and this, the boundaries is 1.
Yes.
So we take Z. So F2 equal YZ. Thank you. What's the code number, please?
18.
Hmm?
1, 8. 18.
18, 1, 8. Okay. Same people, guys. Thank you, Travis. Same people. Please, we need more people.
Thank you.
Thank you, sir. So we add them up. So F equal F1 plus F2, F1 plus F2. F1 is XZ inverted, F2 YZ. So we got the expression. And you can see here, you can't simplify more than this. You can. This is the maximum simplification in one shot, like solving the Carnot map. So therefore F as sum of min terms equal to XZ inverted plus YZ. I mean, we are given this. And from here, we reach it to F as sum of products. Any question, please? The best way to review the Carnot map is today. After we finish and take some rest, go through this part again. Another example here, simplify the Boolean function f given as the sum of min terms. So we need to simplify this expression. To simplify this expression, we have to draw the Carnot map and fill out the min terms and then grouping ones, adjacent ones, then get the product term for each group, add them up, you get the result. So again, what is the meaning of F equal sigma or sum of 0 and 2 and 4 and 5 and 6? What is meant by 0 here? What is meant by 0? Everyone follow?
M0
M0. And what about M0?
is 1.
Is 1. Perfect. What's your code, sir?
7.
Thank you. So again, here is listed here. 0 means M0, 2 M2, 4 M4, 5 M5, 6 M6. And these midterms are ones. Other than this, in the Karnaugh map, for the 3 variables are 0. The midterms are 0. So this is standard one here. The standard Karnaugh map. X, Y here, Z here, because F is function of X and Y and Z. And please, if F is given in terms of X and Y and Z, you must use these variables. Don't put ABC. Some people, despite if it is function of A and B and C, small a and B and C, you must use small a, B, and C. Big A and B and C, you must use big A and B and C. Otherwise, you talk about another problem. So solve the problem based on what you are given. Don't use your own variable since it is given already. So we have small x and y and z, so we use these variables. And then we put the values for each variable. So we have 0, 0, 1, 0, then jump 0, 1, then 1, 1. For z is 0, 1. And the midterm is M0, M1, M2, M3, jump M4, M5, then go back M6, M7. Then now both M0 is 1, M2 is 1, M4 is 1, M6 is 1, M4 is here, M6 is here, and M5. All the midterms given in this function are ones, and the rest are zeros. So after you finish from all ones, you are given just to complete the map with zeros. Now we need to group the ones, adjacent ones. So again, start from 8. Do we have 8 here? 8 adjacent ones?
No.
No. So to move, so we have to move to the list category. So what is the next move? We look at how many ones adjacent?
4.
4. Perfect. Do we have 4 adjacent ones here?
We do.
We do. Perfect. Here we have 1, 1, 1. These are adjacent ones. So we take all these ones in one group. So all these ones, we put it in one group. All these ones here, we put it in one group. So then we look at 2. Do we have? We look at the rest of the map. Of course, we look for 2, if not 1. So at the end, we have 1 left here. We have 1 left here. So should we take this one as own product for this one? Or we can take it with this adjacent one here in one group? Which is better or more accurate?
The adjacent one is better.
Perfect, thank you. So we take these 2 also in another group. Okay, what's your code, ma'am?
20.
20. Okay, Emily, thank you. Okay, so we have 2 product terms here. We need to figure it out. So say, assuming the 4 adjacent ones, the group of 4 adjacent ones, this F1, fundamental product F1 or product term F1, and we need to get F1. So again, we look at the boundaries of F1 here, and looking towards XY or horizontal direction. So what is the values of Y? 0, 1, 1, 0. Different value. So should we take it or skip it? Guys, should we take Y into consideration or we skip it? No answer. This means
Skip.
skip it. Why you don't say anything? We skip it because different values for Y. The same for X, different values, 0, 0, 1, 1. To take it, it must be either one value or different values, but the same number. Either one, all ones, or all zero. But if we have 0 and 1 within the boundaries of the product term, we skip. So we skip X and Y. Then look towards Z or vertically within these boundaries. What we have for Z?
It's just 0.
So just one value with 0. So what we take into consideration? And the product term for this group F1,
Would it be Z inverted?
we take Z inverted. Perfect. Why inverted? Because Z is 0 here. So we have to take it inverted. What's the code say?
31.
Okay, thank you. So we got F1 equal to Z inverted. Here. F1 equals Z inverted. Now we look at this fundamental product. Okay, now one can tell me, please, in XY direction, what we have? Give me the variables we use, the fundamental product. In XY direction, what we have?
X not Y.
What's that?
X not Y.
X not Y or XY inverted. Okay, and in the vertical direction between here and here, because the product term is here. The boundaries of this product term is here. So what about Z? Should we consider Z or not, or skip it?
You don't
Skip
need
it.
to because it's gonna be one
Let's skip
regardless.
it. Exactly. We have two different values. So I hear the lady, what's the code? Lady, please.
20.
20. Okay, thank you, Emily. And the last one, please.
23.
23.
Yes, sir.
Gabriel.
Yes, sir.
Okay, thank you, sir. Thank you. Is this clear for everyone, guys, or not? It is easy.
Yeah.
If you understand it, it is easy. If you follow up, it is easy. But if you are busy with something else, so it will be hard. So now the F is F1 plus F2. F1 is Z inverted, as we did here. F2 is XY inverted, and this is the simplified expression. The one which is given in terms of the main terms here is not simplified. So that's why when we put it in the Carnot map, And then we did like grouping and get the fundamental product for each group. And then we got expression. So you see, we got simplified expression. So all the purpose to get f function simplified. Okay. Any question here, please? Any question? Okay. Another example. You see, we do many examples because examples is the best way to understand whatever we discuss. Of course, beside what we explain. So simplify this expression here. Again, the expression is given by the midterms. So we have three variables. So we have 2 to the power 3, we have 8 squares. So if I give you a problem like this, like just this part here, and I ask you to simplify this expression, can you draw the Karnaugh map, the standard Karnaugh map by yourself or no?
Yeah, you can.
You can.
It should be simple now. We put x, y here and z, and then 0, 0, 1, 0, 1, 1, 0, 1, and 0, 1. And then we put the midterms in order. M0, M1, M2, M3, and we have jump here. So we just M3, after M3, M4 is here. Then M5, then M6, M7. This is the whole story in the Karnaugh map. Then we fill out the midterms. Here M0, here M1, and so on. M0 is 1, M1 is 1, M2 is 1, M4 is 1, M5 is 1, M7 is 1. So M0 is 1, M1 is 1, M2 is 1, M4 is 1, M5, and M7 are 1s. Then the rest are 0. So this is like more than half of the solution now. All we need now to group ones, adjacent ones, grouping adjacent ones. So again, we look at 8 adjacent ones. So we don't have 8. So we look at 4. Do we have 4 adjacent ones here?
Yes.
Yes. Who said yes?
20.
20. Why, Emily? Why we have 4?
Well, we can like overlap the top with the bottom, right?
Exactly. Perfect. Thank you, Emily. Thank you. Double points here. Thank you. Yeah, exactly as Emily mentioned. What happens here? You see these two ones here? This one and this one. And this one and this one. These ones are at the edges. So assume you have the paper like this, okay? Okay. So we have ones at the top and ones at the bottom. And fold it like this. If you fold it, so these ones will be adjacent. Everyone see what I'm saying? If you fold this paper here, these ones will be adjacent. So actually, we have 4 adjacent ones here. But the group is one group, but 2 parts. One part is here, and the other part is here. So when we look at or forward the variables, look at the variables. So we look at the variables between this portion here and this portion here in XY direction. So for this one, we have Y is 0 and 0. So we take Y inverted. So F1, so assume this F1. We take Y inverted. Then in vertical direction towards Z, we look at between the boundaries between here and here. So Z is 0 and 1, two different values, so we skip it. So it just F1 equal to Y inverted. So these four are adjacent. Then we have one here left, and we have one here left. Again, this one, we can take it with this one as one group. And also this one, we can take it with this one as one group. So we have another fundamental product here. If we look at, this is the square of this product. Look at towards X and Y. So we have Y 0 and 1, skip it. X 0, 0, so we take X inverted. We take X inverted. Then look at Z direction. We have Z is only 0, so we take Z inverted. For this one here, F3, towards this direction between Z's boundaries here, we have Y is 1, 0, skip it, X 1, 1, so we take X. Towards Z direction, so within the box, so Z is 1, so we take Z. And we add them up, F1 plus F2 plus F3, we get this expression. Simplify. If you try to do more simplification using Boolean algebra, you can, because this is the maximum simplification you get. Any question here? Any questions? If you don't ask, this means everything is clear.
Nope, no questions.
Yeah. For everyone, no question. So this means it's clear for everyone. But if something not clear and you don't ask, this is the problem. You know. If not clear, you have to ask. I can repeat 100 times, no problem. But please tell me if nothing. I mean, if something not clear, tell me.
Professor? Sorry, I just realized one question.
Yeah, go ahead.
Why isn't M0 and M1 grouped together? What are they?
M0 and M1?
Yeah.
M0 and M1, a group with M4 and M5. This is
I
M1.
see. So they are
Because
repeated.
if you fold the paper, because these ones are at the edges. So if you fold the paper, they will be adjacent.
Okay,
So we took them in one group.
I see.
Okay. Let us take like 5 minutes, please. 5 minutes break. So 3:40 now, like 3:45. Okay. And then we'll talk about this example. Okay, so just 5 minutes break, please. Okay. Welcome back, everyone. Now, we have this example here. This is like a comprehensive example now for this part. So we are given this Boolean function, and we need to express this function as a sum of min terms, and then we need to find the minimal sum of product expression. It means maximum simplification. So to get this expression, or f, this function, as a sum of min terms, we need to draw the truth table. We need to draw the truth table. So from the truth table, we got M0, M1, M2, M3, M4, so we can get this f in terms of the min terms, where m is 1. So we get this from the truth table. Now, to draw the truth table from this expression here, can we do that directly? Or we have something missed in this expression we need to complete first? What do you think? What do you think?
I think we can.
We can?
Yeah.
What's your code?
27.
Grant?
Yeah.
27 grant minus 1. No, don't worry. Of course we can't. We cannot. Why? Look at the terms, Grant, here.
Yeah.
Or f. Is f in standard form? No.
No.
If it is not in standard form, we can't get the truth table. It must be in standard form. Why it is not in standard form? Why?
Each term doesn't have one or all
Exactly.
three.
Thank you. It's still Grant or someone else?
That was number 3.
Number 3. Yeah. Oh, okay. Thank you, Bang. Is not in standard form. Why? Look at this term here. A inverted C. Second term, A inverted B. Then A, B inverted C. So here we have 3 variables, A, B, C. But some product terms has 2 only. So this is not a standard form, as we discussed before. So we must get each product term here in 3 variables, not less than 3 variables. So what we do to get A inverted C as 3 variables? How we converted? What is missed here? Which variable is missed here?
You multiply it by b plus b inverted.
So B is missed, right?
Yeah.
In this term here, B is missed. So we multiply by B plus B inverted. Plus A inverted B. What is missed here? C. So we multiply this by C plus C inverted. Plus AB inverted C. This is okay. Plus BC. So miss the A. So we multiply by A plus A inverted. This is how we convert from this not a standard form for F to standard form. Because we can't draw the truth table unless this function is given in standard form. But it is given in, as you see here, in this form, which is not standard. So we have to convert it to standard form first, like we did now. Then multiply A inverted CB plus A inverted CB inverted plus A inverted BC plus ABC inverted, and so on. After we do that, there is another important step before we go to the truth table. What is this point? What is this step? Believe I mentioned this before, believe me. After we convert to standard form, we have to look at something important. What is that?
Whether or not there's any like repeated terms.
Can you speak loudly, please?
Whether or not there's any repeated terms.
Yeah, exactly. What's your code, sir?
3-0.
Thank you so much. Exactly. We look at the repeated terms. If we have terms repeated, what we do?
Cancel them out.
We take only one term and skip the rest repeated ones. So, for example, here you can see A inverted BC. A inverted CB is the same as BC, of course. So we have A inverted CB here. This term. We have this term, also the same. We have this term, also the same. So we take only this one and skip this one, skip this one. So if we have a term repeated 4 times, so we take one term of them and skip the rest. Then the other term is here. Okay, now. So the final standard expression is here. So from here we can get now the truth table, complete truth table. So we put CBA or arrange the truth table in this. So we mentioned to draw the Karnaugh map correctly, we should start from A, B, C, or X, Y, Z, like this, and put 0, 1, 0, 1, 0, 1, then 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 0, 0, 1, 1, 1, 1. Double the zeros and ones. If every movement from one variable to the next one, double the numbers. Then put F. We don't know F yet. F is the value of F. We don't know yet. But we are given these product terms. So we have to figure out where these product terms in the truth table verse. And the corresponding F will be 1. So let us look at the first one. A inverted CB. A inverted means A is 0. And C is 1 and B is 1. So we look at that in the table here. Where is A is 0? A is 0 here in the first 4 rows. Okay. Then where is C is 1? Where is B is 1? B is 1 here. So we focus in these 2 rows. Then where is C? Where C is 1 is here. So A inverted CB is this row here. And the F equal to 1 in front of this product term. Because we mentioned F equal to 1 at each of these product terms. Then we look at the second one. The second one, A inverted, CB inverted. Again, A inverted. Where is A inverted means A is 0. So the first 4 rows. Then B inverted. B inverted means B0. Where is B0? First 2 rows. So our search focus on the first 2 rows. Then C is 1. So we have this one here. A inverted C, B inverted this row here. And in front of this row, F is 1. Then look at the next one. The same thing. A inverted, B, C inverted. So where is A is 0, is here. Where is C is 0, is here and here. And then B is 1, so is here. So this row, the fundamental product is 1. And so on. The last one is BCA. So B is 1, C is 1, E is 1. So the fundamental product here is 1. Then we just put them in terms M0, M1, M2, M3 in sequence. So now if in terms of the min terms, where is the min terms? We have ones. Is M1 plus M2 plus M3 plus M5 plus M7. But we can put this directly now because we know. So we just put the sum, open bracket. M1 means 1, M2 means 2, comma 2, then comma 3, then comma 5, then comma 7. So we got the first part here, A. F in terms of the min terms. Everyone agree with this so far? Any question? Any questions, please? Okay. Now the next step, we need to minimize. So we draw Karnaugh map. We draw Karnaugh map. Again, the standard Karnaugh map for 3 variables. Then we fill out the min terms for these ones. M1 is 1, M2 is 1, M3 is 1, and so on. Then we're grouping the ones, adjacent ones. So we look at 8, we don't have. We look at 4, we can see here we have 4. So we take them in one box or one group here. This one group. Then we have one left here. So we can take it with this one as another group. So we have 2 groups. The first group is this like F1. So we look at towards A and B variables. So we have different values. So we skip it. Towards within this group, we look at C. So C is 1. So we take C. So F1 equals C. Then we look at the other group, F2. Towards AB, we have A is 0, one value with 0. So we take A inverted. And then B is 1, so we take B. Towards C, C has 2 different values, 0 and 1, so we skip. So F as best simplification is F1 plus F2, which is C plus A inverted B. Any question, please? Any question here? Any question? Okay, no question. So let us move forward. Four variables. So we finished with 2 variables, 3 variables, now 4 variables. So we have 4 inputs. We have 4 bits applied as the input of the system. And we need to get F, the output function. I mean, we need to look at it. So 4 variables means n equal to 4. So 2 to the power 4 equals 16 min terms. And the standard Karnaugh map for 16 squares is this one. Everyone sees this slide or not?
I see it.
So we have four variables like a w omega x or wxyz, wxyz, or abcd. So we put omega x or wx here, yz is here, or if in terms abcd, so we put ab here and cd is here. So 0, 0, 1, 0, jump 0, 1, then 1, 1. The same now for yz because these two variables 0, 0, 1, 0, jump 0, 1, then 1, 1. Like in decimal, we have 0, 1, then jump to 2 here, then go back to 3. So consequently, when we put the min terms, we start with M0, M1, then jump M2, go back M3, then M4, M5, jump M6, M7. Then jump here, because we have jump here, so M7, so M8 here, M9, then jump M10, M11, M12, M13, jump M14, M15. So this is how to fill out the Karnaugh map with min terms in general. But after that, we have to look at what M0 is 1 or 0, M1 is 1 or 0, and to fill out this map with zeros and ones. Example, simplify the Boolean function given in terms of min terms here. So all these min terms listed are ones. So we have the standard Karnaugh map as we listed here. And then we fill out the map with these min terms. These are ones. So M0 is 1, M1 is 1, M2 is 1 here, then, and so on, based on what we are given here. Now we need to group adjacent ones. So we start with 8. We start with 8 adjacent ones. Do we have 8 adjacent ones here?
We do.
We do. It's here. This is square here. This group here of ones. These are ones. Perfect. Can we use a fundamental product or the product term for this? So say F1. Look at towards Wx between the boundaries of the box here. So what you see, X has different values, Y has W has different values. So we skip both W and X. Look at the boundaries here for this box. So what we have? We have Y is 0, 0. So what we take? Y inverted. Why not? Perfect. Z is 0, 1. So we skip. We skip Z. So F1 is just equal Y inverted. We should actually group ones first, and then we calculate the fundamental product or product term. But I just put the expression for this fundamental product just for this case to see what we get in this case. Looking to the other ones, other groups of ones. So we're done with these 4 ones here, but we have 1 here and 1 here and 1 here. We can't take 3 adjacent ones as one group. We can't. We mentioned either 8 or 4 or 2, but we can't take 3. So what we do here, so we can take this one and this one in one group. Do we have better choice than this? Remember, more grouping of ones, better simplification. You don't have to use Boolean algebra after you get the expression if you choose the optimum grouping of ones, adjacent one. So one may say, oh, I take this one and this one as one group here. Do you think is this good choice? Proper choice, I mean? No. Perfect. Why? I mentioned we can't take 3 as one group. The groups either 8 or 4 or 2 or 1. But we can't take 3. So again, so we can't take these 3. But instead of taking this one in M2 and M6 as one group, look at the other side here. Again, these ones on the edges. So they are adjacent actually. So we can take this group with this group, as one group. This part and this part. Now look at the fundamental or product term of this 2 portions. There's one box or one group, but 2 portions. So towards X, W and X, the boundaries from here to here. So what we have, we take W inverted, and we skip X because 0, 1. Then we look at towards YZ in this boundary here and this boundary here, because this is the 2 portions. So what we have Y and Z in these portions. Y is 0, 1. So skip it. Z is 0, 0. So we take Z inverted. So we're done with this group. F2. Now what is left? This one is left. Okay. One may say, oh, I take it in one group. Is this good choice? Of course not. One say, oh, I take this one and this one in one group. Is this a good choice? No. Why? Because again, we mentioned grouping 8, 4, 2. Can we take this one in a group of 4 ones or not? Of course, yes, we can. Again, look at this group here and this group here. We can take it in one group. And this like F3. Again, F3, we have here W01, skip it, X 1, 1, so we take X. Then for this portion here, we have Y is 0, 1, skip it, Z is 0, 0, so we take Z inverse. So we have F1 and F2 and F3. We add them up. We got this expression simplified. If you try to do more simplification, you can, because this is the maximum simplification we get. And we got this because we did optimum choice here for grouping ones. We did the best thing for this. If the other options, if you do the other options like we mentioned, this is not good choice, like one left here, so can we take it in one group with this one? If you do that, you will get expression, it still needs simplification. It still needs simplification. So after Karnaugh map, and you do simplification again, definitely this is not good, because from Karnaugh map, I should get the maximum simplification we can do. Okay. Okay. Simplify the Boolean function, another example. So f equal to these, given these product terms. But again, simplify. To simplify, we need to get the truth table, because we are given f equal to this. But this, again, is not standard form, because the maximum number of variables here is A, B, C, D, based on this term here. But we can see in the first term, we have A inverted, A, B, C, whatever, inverted or not. So we have D missed here. Here we have B missed. Here we have D missed. So again, do the same thing. Multiply here by D plus D inverted. Multiply here by B plus B inverted. This is okay. For the last one, we need to multiply by D plus D inverted. So we got these expressions. When we compare, we can see a term repeated here, so we just cancel or skip it. And then we do, since we have standard form now, we can draw the truth table. So again, to do that, start with A, B, C, D, and then put F. We don't know F yet. So we leave it until we get the product terms. And of course, here's the min terms in order. So D start D 0, 1, 0, 1, C 0, 0, 1, 1, and so on. Then B 0, 0, 0, 0, 1, 1, 1, 1. Then A, double the numbers as we mentioned. And now let us look at the first product term. A inverted, B inverted, C inverted, D. So A inverted means we talk about A0. So we look at here. Is one row of these rows. Oh, sorry. Then B inverted. So now the number of rows shrink to this part here for B0. Then C inverted. So shrink to this two rows. Then D. So we have D is one here. So this is the term A inverted, B inverted, C inverted, D is here. So F is 1 for here. Then the next one, A inverted, B inverted, C inverted, D inverted. So like A inverted, A0, B0, C0, and D is 0, which is here. So this is the second one. And so on, the same thing. For each product term, you figure it out here, you figure out which row, the corresponding fundamental product is 1. Now, in terms of F, in terms of the min terms, what we have, M0, M1, M2, M6, M8, M9, and the rest are zeros. So we draw the Karnaugh map, and then we put M0 is 1, M1 is 1, M2 is 1, M3 is 0 because it's not listed here. So look at where is 1. M6 is 1, M8 is 1, M9 is 1. And the rest are zeros. Now, grouping ones, 8, we don't have 8. 4, we have 4. These two ones and these two ones, they are 4. So we take it in one group, but one group divided in two parts, but still one group. with boundaries for vertical boundaries from here to here. For vertical boundaries towards C and D from here to here. So we have C is 0, 0, and D is 0, 1. So we skip C, we skip D, and we take C inverted. We take C inverted. For towards AB, so we have this portion and this portion. So we look at what happens for A and B within these portions. A is 0 and 1, skip A. B is 0 and 0, so we take B inverted. So this is F1. Then we have 1 and 1 left here, so we can take it in one go. So F2 is, again, look at in this direction. A is 0, so we have A inverted. B skip it. C, in this direction, C is 1, so we take C. D is 0, so D inverted. This is D inverted. Okay? Then we add F1 plus F2, we got the expression here. Again, 5 and more variables is not visible here. Another part is important here regarding Karnaugh map is another condition, important condition here is called don't care condition. X. For don't care, we put X. What this means? What is meant by don't care? Don't care means a don't care midterm means a combination of variables whose logical value is not specified. So in the Karnaugh map, if we have midterm, one of midterms or more than one, instead of 0 or 1, you see X inside the midterm, inside the box. X means the value here is not specified. It may be 0 or 1. It may be 0 or 1. It doesn't matter. Either 0, so you get the same function as the output. 1, you get the same function as the output. Okay? So it doesn't matter. So if the midterm is marked X, means don't care, you may consider this midterm either 0 or 1. Is up to your choice. Is this important for simplification? Of course, very important. How? Let us look at this example here. Simplify the Boolean function f equal to this in terms of the midterms. Guys, I see some people left. If you leave, if someone left and I called the name and I didn't hear the response, so this will be absent. Okay? I try to wish you to follow up and stay because this is important. Okay? You should know this. Yeah. I should not say this because this is your knowledge and your skills. But unfortunately, you know, some people need to get some push. Okay, so please don't leave. Unless something true urgent, true emergency, and tell me, either chat with me before you leave, but don't leave like this, please. Okay? I repeat, if you have any question, please ask. So imagine you leave. Doesn't make any sense, right? Okay, some people, I'm not talking about you, you are here, but unfortunately, some other people. Okay, so f equal to this, and also given which has a don't care condition, this. D here stands for don't care. So f is the function, the Boolean function here, f is the Boolean function. This d means don't care, refers to don't care. So don't care for min terms M0, M0, M2, and M5. So at M0 you put X, at M2 you put X, at M5 you put X. But here at F, this is M1, M3, and so on, you put 1, 1, okay? And so on. So we have the standard Karnaugh map, and then we fill out F based on M1 is 1, M3 is 1, M1 is 1, M3 is 1, M7 is 1, M11 is 1. And M15 is 1. Okay, again, the standard Karnaugh map is we mentioned here, okay? So don't is here. Let's see. So just you fill out this. Okay, then now don't care. Where is the don't care? M0, don't care. You see this X at M0. M2, X. M5X, don't care. What is the benefit of these don't cares? Let us group adjacent ones. So do we have 8 adjacent ones? No. Do we have 4? Yes. We have 4 here. We have 4 here. Okay. And immediately we can get the fundamental, the product term for this. Look at these dimensions here. So we have X different values, W different values. So skip W and X and look at the boundaries here. Y is 1 and Z is 1. So if Y, Z. F2, we call it F2 here. Now we have this one left here. This one is left here. One may say, oh, I can take it in a group like this. With M3. Is this proper choice, do you think? Of course not. Why? We have don't care here. And we have don't care here. And we mentioned for don't care, we can consider it once. So since we have 4 adjacent ones here, it's much better to take it in one group than just to take a group of 2 adjacent ones. So this is the benefit of don't care. If we have don't care adjacent to 2 ones, so they may be helpful to get better group of adjacent ones. We mentioned we are looking first for 8. If not, so for 4. So this gives us 4. That's much better than 2. So definitely we take the whole thing here as one product term or one group. Despite we have don't care here and don't care. Simply consider we have 1 here and 1 here. So 1, 1, 1, 1, we take it in one group. So for this group, if 1 is W0, so W inverted, X0, X inverted, and from here to here, we have different values for Y and Z, so we skip. So now we got W inverted, X inverted, and plus YZ. Is this clear, guys? Don't care and grouping of Karnaugh map or of 4 variables.
Professor?
Clear?
Professor?
Yes, sir. Go ahead.
If M2 is just 0 and
M2 is 0.
if M2 is just 0 and 0 is don't care. How would we group
M2 is 0, M2 is 0, okay?
if M2 is 0
Yeah,
and
yeah.
I mean, F2 is 0 and M0 is don't care? Then how would we group M1 and M3?
Yeah, you will take M1 plus M3 only. You say M0 is don't care, right? Assuming.
Yeah,
And M2 is 0.
yeah.
So you don't have 4 here. So we just take M1 plus we take
Okay.
M1 and M3 in one group.
Okay.
Because again, as we mentioned, we look at A, then 4, then 2. So if M2 is 0, so we don't have 4 now. We just have we have like 3 M0 if we consider, but in this case it doesn't help if we consider it like 1, because even if it is 1, the group is still only 3 ones, so it doesn't. So we just take one group of M1 and M3. Okay.
I see. Thank you.
You're welcome. The last thing here, this negative OR gate. We heard about OR gate, of course. So OR gate is the same like this without these bubbles. So if we have these bubbles, this means we have negative OR gate. What this means? This means the output here, Y, and instead of equal A plus B for regular OR gate, so is A inverted plus B inverted. Because this bubble here is just actually the input is A, and due to this bubble, this A goes inside the gate as A inverted due to this bubble. The same for B. So the output is A inverted plus B inverted. So this is called negative OR gate. Negative AND gate, the same thing. Regular AND gate, Y equal AB, logic multiplication, of course. But because of this bubble here, A goes okay as A until hit this bubble inverted. This bubble like inverter, like not gate. So goes to A inverted and B inverted. So instead of Y equal AB, it is A inverted, B inverted. Any questions, please? So the midterm, we still have class next time, next meeting, in Thursday, right? On Thursday we have class meeting. So we have regular class, but the midterm is on July 8th up to here, up to the end of this part here. Okay, I'll just let you know. Okay, any questions, please? Any questions so far?
No questions.
Okay, thank you,
No
everyone.
questions?
Yes, sir.
No questions.
Okay.
That was good.
Okay, thank you, everyone.
Have a good evening.
Have a good day. Take
Thank you,
care.
Professor.
Thank you,
Thank you.
man.
Professor, I
Thank
have a
you.
question.
Yeah, go ahead.
So for
If you don't have question, you can leave. Take care. Bye. If you
Thank you,
have
Professor.
question, just stay. Okay.